Três Atlas! Sejam bem-vindos para mais um vídeo aqui no canal para a gente discutir sobre o Três Atlas. É uma nave alienígena? É uma sonda? Tem vida ali dentro? É um cometa? É um asteroide? Nós já temos aqui no canal com física, matemática, estatística, tudo que você possa imaginar, até análise de dados com Python, 9 vídeos sobre o Três Atlas. Esse daqui está sendo o 10º. Só que desta vez, neste vídeo aqui, diferente de todos os outros, eu vou ganhar a sua inscrição no canal. Dessa vez eu vou ganhar seu like. Você vai falar, Hime, eu vou me inscrever no canal só por causa desse vídeo. Por que, Hime? O que você fez de diferente agora neste vídeo? Por que você merece a inscrição no canal? Por que você merece que eu compartilhe, hype o vídeo e conte para todo mundo para se inscrever nesse canal? Ladies and gentlemen, Professor Avi Loeb from Harvard University. Professor Loeb, thank you very much for being here. It's a great honor for me to have this conversation with you. Allow me to start by saying that I share your view that science needs to be a bit more open-minded, let's say, though within the scientific method. For example, I recently made a video series about 3i Atlas where I just asked, what if? What if it's aliens? And by doing that, I was able to teach math, physics, statistics of comets and asteroids, how to treat raw Hubble Space Telescope data, and even how to use NASA's Horizon systems for ephemerids. And as a science communicator, I realized that I will never reach such wide audience if I stayed in the rigid mindset that we already know the answer, you know, and the simple act of asking what if opened the door to real curiosity, and that's a win for me. Here on YouTube, I see that every day we lose people to conspiracy theories, and my argument is that scientists are not able, they are not doing their job very well communicating with the society. And my question is, in your experience, how important do you think creative imagination is in science today? And how can we encourage scientists to be a bit less rigid?
Well, thank you so much for inviting me, and I completely resonate with what you say. Science is a method for learning something new. And it's a learning experience, and it's work in progress. And very often we might be wrong. And the way to correct ourselves is to attend to data. But the one thing that is not often understood is that in order to get data, you need to be curious. Because if you think that you know the answer in advance and you pretend to be the adult in the room, you would argue that we don't need more data. And that obviously was the point of view of the Vatican when they put Galileo in house arrest. And I would much rather have the Vatican say, we don't agree with Galileo, and we want to show that he's wrong by looking through our own telescopes. So they would have built bigger telescopes, better telescopes, because they had more money than Galileo. And then they would look through these telescopes and convince themselves that he's right. And they would have saved themselves the embarrassment of admitting that 350 years after he died. Because at that point, it was obvious from images we get from satellites and the space probes that the Earth is moving around the sun. And it makes no sense for the Vatican to continue to insist that the Earth is at the center of the universe. So my point is, it's a different strategy. If someone disputes the common belief, that should not be censored, because the only way for us to discover the unexpected is not to expect it.
Yeah.
And totally. Therefore, we should be encouraged to collect data that would rule out the unexpected, okay, that would show that our current thinking is correct, but we should not censor deviations from the current paradigm. And I find this example of 3i Atlas indeed very educational, because the public cares a lot about whether we are alone in the universe, whether we have a neighbor, whether there is a smarter kid on our cosmic block, and that would have huge implications for the future of humanity. My hope is it will bring people together because we would all realize that we are in the same boat here on Earth. And instead of fighting each other, engaging in conflicts on territories on this planet, we would aspire for something bigger and better. It will bring us to a better state of mind. That's my hope. But in order to accomplish that, we really need to search for our neighbors. And, you know, if we say that anything in our backyard must be a rock, because we've seen a lot of rocks in our backyard, so anything that comes from the street must also be a rock, like the ones we have in our backyard, then we might miss on a tennis ball that was thrown by a neighbor. And how do we decide whether something is worth studying? It's when it shows anomalies. And I use this example of three-eye atlas to demonstrate that, you know, here is an object that has unusual characteristics. Let's collect as much data as possible because it's possible that it was technological in origin. So why do I bring this up? You know, obviously I'm not hallucinating or just imagining this possibility. I was driven to it by the data we have on three-eye atlas. In particular, it's relatively bright. And when you ask how big should an object be to provide this brightness by reflecting sunlight, you find 20 kilometers in diameter. You know, that's bigger than Manhattan Island. It's huge. It's twice as big as the rock that killed the non-avian dinosaurs 66 million years ago. So these things are very rare. And, you know, there are hundreds of thousands of objects that are roughly 100 meters in size for every object that is 20 kilometers in size in the solar system. And the previous interstellar objects from outside the solar system that we saw were in the range of hundreds of meters. There were two of them. And suddenly we see a 20 kilometer. That makes no sense. We should have seen hundreds of thousands of those that we've seen before we see this one. Another issue is that there is not enough rocky material in interstellar space to deliver us a 20-kilometer rock over a period of 10 years that we've been doing this survey. And, you know, we would expect such a big object once per 10,000 years. You know, that's extremely rare. And so that leads me to consider the possibility that if it's that big, if it's of the order of 20 kilometers, then maybe it targeted the inner solar system. It has nothing to do with the reservoir of rocks in interstellar space. And people say, yeah, it's a comet because there is some glow around it that looks like a coma. But comets are characterized by the tail they have, because if there is dust emitted by, or gas emitted by the comet when it's warmed up by the sun, then this gas is swept back by the solar wind. And the dust particles often get swept up behind the nucleus by the solar radiation pressure. And so you end up with a cometary tail. That's what we usually see. However, in this case, the Hubble Space Telescope obtained an image, and we see glow in front of the object. So people look at that image and say, oh, there is some glow, but realize that this is a glow into which the object is moving. It's not behind it, it's in front of it. And if that was the usual cometary material, you know, we would see it trailing in a beautiful tail behind it. And the other thing is, with spectroscopic observations of this object did not find any spectral fingerprints of molecules that usually accompany comets. There is no evidence for gas around it.
At least for now, actually.
For now, exactly. Yeah. If it gets close, so, you know, science, the beauty of the fun of doing science is like a detective story. You know, as time goes on, we get more data, so we can improve our understanding. It's not as if what I say must be set in stone. As it gets closer to the sun, if it's a comet, it should erupt. We should see outgassing. We should see a cometary tail behind it. Everything should be clearer because it's closer to us, closer to the sun. It's warmed up. And of course, if it shows all these features, if it looks like a duck and quacks like a duck, you know, it's a duck. Okay, yeah. So, I defined a new scale that is now called the Loeb scale. There was a paper about it this morning on the Astrophysics Archive. where 0 is a natural object, like a comet, if we know it for sure. And 10 would be a technological object that we see, for example, we see it maneuvering in ways that implies some engine. We see some artificial lights coming from it, or we see that it transmits or broadcasts some signal, things that indicate that it must be technological. And so at this time, I would not give it more than 4 on the scale between 0 and 10. But the main reason I give it a 4 is not what I said until now. It's actually the trajectory of this object. If you look at the 3-dimensional illustration of the trajectory, it lies exactly in the plane of the planets around the sun. And the chance for that happening is 1 in 500. And it goes on a retrograde orbit. So if it were technological and it wanted to release any mini probes that would intercept the planets, that's perfectly oriented, because the planets will move into the mini probes as this object is passing through the inner solar system. And speaking about that, the timing of the arrival is very fine-tuned, because it passes very close, within a fraction of the Earth-Sun separation, from Mars, Venus, and Jupiter. And the chance of it passing so close to these planets is 1 in 20,000, if you just allow for the arrival time to be arbitrary. And it arrives closest to the sun on October 29th, this year, 2025, when the Earth is on the opposite side. So we won't be able to see it. When it could do a maneuver, we won't be able to intercept it with any rocket, because it's moving at almost 100 kilometers per second relative to Earth when it passes closest to the sun. So for all these reasons, I say, let's keep our eyes open. Let's, as basketball coaches often say, let's keep our eyes on the ball, not on arguing with each other on social media, but on the ball, which is 3i Atlas, collecting as much data as possible. Because if it happens to be technological, then the stock market may crash.
Yeah, definitely. Yeah, I already made a video about your scale, the Loeb scale. In my opinion, I would say it's I would rank 2, but that's my
Okay.
my humble opinion. Specifically because I think, well, if it's an advanced civilization, they might don't even care to be like, I'll go in the opposite side of the sun. I mean, they don't might even care about it if they are really more powerful than us, But
well, it depends. It's not really a match with our powers. If it's a mission intended to collect data, then they would do whatever is best and easiest for them to collect that data. Now, we cannot guess the intent, of course. And, at some point, I wondered whether we should transmit a signal to this object and figure out if there is any response, because we cannot reach it with any rocket from Earth, but we can easily reach it with a light beam, because it moves at 3,000 times slower than the speed of light. Also, I realized that there is a spacecraft around Jupiter that is called Juno, and it was about to be sent into Jupiter because of the end of the mission in mid-September 2025. And I suggested that instead of giving it a push into Jupiter, giving it a push away from Jupiter, so that by the middle of March 2026, when the 3i Atlas comes closest to Jupiter, it will be able to get close to that and close to that path, and actually probe it, with all the instruments that exist on Juno, that will give us new information that we can't really access from the Earth.
Yeah, I like to spark imagination. So for me, I always try to think out of the box. So just imagine. I mean, we have the second law of Kepler to determine the orbit and velocity, speed, and stuff like that. Just imagine for one moment that after passing our sun, we then decide to try an observation with the James Webb, and it is not there. It is possible. It is possible.
Yeah.
So what?
And by the way, that possibility is extremely appealing to the public. That's why
Yeah.
we don't have a lot of options for getting the public excited about science. If the Large Hadron Collider were to discover a new particle, it wouldn't affect people's lives and they wouldn't feel connected to it. But finding another intelligent civilization this way, obviously based on science fiction stories, and it's a blind date of interstellar proportions. And in a blind date, my advice is to observe the other side rather than to have an opinion in advance, because our imagination is very limited to what we've seen already on Earth, and it could be something completely different. Now, just that possibility by itself is worth considering, because Blaise Pascal had the Pascal wager about God. He said we should not dismiss the possibility that God exists, because if it is true, then it has huge implications. And I argue the same applies to a technological object from interstellar space. The implications are huge, and therefore we should examine each and every object to be discovered by the Rubin Observatory in Chile over the coming decade. We expect one new finding every few months.
I watched your TED Talk, and one phrase that struck me was when you said extraordinary claims require extraordinary evidence, from Carl Sagan, of course, but that requires extraordinary funding. And yet most scientists don't even seem very concerned about actually looking for such evidence. So
no, that's exactly right, because very often our ignorance is a self-fulfilling prophecy. We say something, it has no evidence to support it, and therefore we do not invest in the resources in doing the search for that thing, and we will never find it. So then it's a circular argument. Now, just to give you an example, the mainstream of cosmologists or astronomers suggested for 40 years, since I started doing astrophysics, the suggestion was the dark matter, which is most of the matter in the universe, 85% of the matter is of a substance. We don't know what it is. It's invisible. And so there was a popular view that it's a supersymmetric particle which is weakly interacting. And that was the paradigm. Everyone in the mainstream said, yes, it's very reasonable. People got awards, honors. They got recognized for just suggesting it. Then the Large Hadron Collider did not find supersymmetry in the natural range of parameters, did not find a dark matter particle. We now have, at the cost of billions of dollars, we have very tight limits on those parameters. Now, I say, well, if the mainstream is taking an approach that is risky and getting it wrong, then, what I'm suggesting is far less risky, because we know that we exist on a planet near the sun, and we know of analogs of Earth-Sun system. There are probably billions of them in the Milky Way galaxy, and under similar circumstances, arguing that something like us exists, is not speculative at all. And moreover, it would take a billion years for the Voyager spacecraft that we produced to sample all the stars in the Milky Way disk. In principle, it could get to any of them. However, most of the stars formed billions of years before the sun. So there was plenty of time for any of their technological gadgets to reach our backyard. And therefore, we have an obligation to search for that. And this is a very different search method. It's like looking for a package in your mailbox. The sender may be dead. Who cares? The package is in your mailbox. That's very different from waiting for a phone call, which is what the SETI community did for 60 years, like looking for a radio signal. And it's very different from a radio signal, because if you have a visitor to your backyard, that visitor may enter through the front door, and you have to decide how to respond to it immediately. Whereas if you get a radio signal from a source that is thousands of light years away, you have plenty of time to respond. You don't need to worry about any immediate risk. So I think this is a whole new frontier that is opened up by the discovery of interstellar objects over the past decade.
It's very simple, actually. So how can we ever hope to find what might exist if we are not really searching? That's the point.
Exactly. And my point is, since the public cares so much about it, and I refuse to behave like the adults in the room, science can be fun. Science is exploratory. You are allowed to ask any question you want, and then the scientific method is finding the evidence. And because the public cares so much about it, I'm hopeful, that the young generation of today will find the science appealing as a result of these, 3i Atlas or other objects. And as a result of that, they will pursue the evidence. The mainstream of the astronomy community is willing to invest more than $10 billion as the highest priority to search through about 20 to 30 exoplanets and look for the molecular fingerprints of molecules like oxygen, water, methane in those atmospheres as the testimony for the existence of microbes, just microbes. And even these molecules cannot tell us conclusively that they were not produced by some geological process. But I'm saying let's hedge our bets. It's quite likely, if you look at the houses on your street, that the houses that look just like yours have microbes, but it's very difficult to detect them from a distance, okay? However, if there is some resident in these houses, you might see a much clearer signature of the resident. You might find a tennis ball in your backyard, or you might actually see that the resident approaching you. And therefore, I'm saying we should hedge our bets. We don't know if we have residents in those Earth-Sun analogs, but we should search for any artifacts. I call it interstellar archaeology, searching for relics that they left behind.
Let me ask you a very good question. From a Bayesian perspective, what do you consider a reasonable prior for extraterrestrial life? Say, intelligent technological life in the Milky Way or the universe? Are we talking 1 in a billion, 1 in a million, 1 in 1,000, or something else?
I'm an optimist. So you see, and the reason I'm an optimist is because life is sometimes a self-fulfilling prophecy. And the reason I say that, if you ever went on the dating scene, there are people who are very pessimistic. They say in advance, there is nobody good enough that I can find as a partner. And
that would be 1 in 0.
No, they say, where is everybody? Just like Enrico Fermi,
Yeah.
And I saw many of these people stay lonely, okay? Because in advance they say there is probably nobody for me out there.
Mm-hmm.
However, if you are an optimist and you go to dating sites, you search for it, there is a chance you will find something. Now that depends not just on you, it depends on the pool of potential partners, if it's out there. And I'm preferring to believe that there is a big pool of interstellar artifacts for us to find as evidence of other civilizations, for the simple reason that it's sufficient to have one civilization that is extremely advanced, had many more years of science and technology than we did. We just had about a century, and if they had thousands, millions, or billions of years, they could have developed the capability of making self-replicating probes, and then you can very quickly fill up the Milky Way galaxy with gadgets. Whether there was such a civilization or not remains to be seen by searching. And right now, there is no federal funding allocated for the search of intelligent civilizations, whereas, at least in the US, more than $10 billion are currently planned to be spent on searching in 25 or so exoplanets the molecular fingerprints of microbes. Microbes are much less inspiring for me compared to someone who happens to be a better student in the class of intelligent civilization, for the simple reason we can learn from a smarter civilization, whereas microbes will just tell us about primitive forms of life.
You have mentioned that the Vera Rubin Observatory will likely detect many more interstellar objects, but if the scientific community maintains the rigid perspective that they must always be either comets or asteroid, isn't there a real risk that we might overlook evidence that some of them could be something else, maybe even probes? And after all, we ourselves have sent out the Voyagers, right? If such probes were to pass through another planetary system, I just imagine maybe civilizations there might just dismiss them as ordinary asteroids. Do you think we could be making the same mistake?
I mean, on January 2nd, 2025, the Minor Planet Center announced a near-Earth asteroid that passed close to Earth. And then they realized that the trajectory of this one was the same as the Tesla Roadster car that was launched by SpaceX. So they immediately removed it from their catalog because it was not a rock, it was a car. Okay, and I'm just saying maybe Elon Musk is not the most accomplished space entrepreneur since the Big Bang. And that was 13.8 billion years ago, and there might have been even better entrepreneurs in the Milky Way galaxy, and we should search for whatever interstellar cars they produced. Now, it also tells you that astronomers will if we don't know that we launched this object, they will immediately catalog it as an asteroid. And and so we should be careful because traditional thinking is not necessarily a guarantee to discovery. Until 1803, it was thought that there are no rocks from the sky, and then a French physicist, Bayot, went to a meteor shower and demonstrated that rocks fall from the sky. And now my colleagues, the experts, forgot about the fact that after Sputnik 1 in 1957, there were lots of technological objects that were added to the reservoir of rocks in the solar system. And so if we do that, why can't we imagine that other civilizations may have done that? So, but they still have the mindset that any object entering the solar system must be a rock.
One final question. When I read that a Netflix film crew has been following your expeditions with the Galileo project, including your trip to, I think it was Papua New Guinea.
Yes.
I'm curious if there is any update about the documentary. Do you know when it might be released or any working title yet?
They actually continue to follow me, but they told me that in early 2026, hopefully it will come out. I'm actually finishing a book now with MIT Press about the expedition to the Pacific Ocean to search for the materials of an interstellar meteor. So this is a small object like 0.5 meter in size that collided with Earth in 2014. And the fireball was detected by US government satellites. And we went to find the materials from it to figure out its nature, whether it's natural or artificial. So, it's exciting. I was once asked by a podcaster, how do I want to be remembered in the future? And I said, by my future work. Because I hope to discover something much more important than I did so far. And also I was asked, are you doing this just to get the Nobel Prize? And I said, not at all. Because if I find the alien intelligence, I would not waste my time going to Stockholm to get a prize that is given by humans to humans. I would much rather try to figure out what the alien intelligence is doing. It's sort of the approach that Bob Dylan took towards the Nobel Committee.
It might be just like the three-body problem, science fiction.
Well, everything is possible. I would argue that nature is more imaginative than humans.
Yeah.
And for example, nobody expected quantum mechanics to describe reality. And therefore, we should be open-minded. There might be things out there, that are far beyond what script writers in Hollywood imagined in science fiction stories.
Professor Loeb, thank you very much for being here for this conversation. I really enjoyed, and please keep your good work.
Thanks for having me, and I also enjoyed your questions and comments. Thank you.
Thank you. Gostou do vídeo? Inscreva-se no canal. Tamo junto, galera.